This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Auth0 is the easiest and fastest way to implement authentication and authorization architectures into your apps and APIs. Allow your users to log in with username and password, social and enterprise identity providers such as Facebook, Twitter, AD, or Office 365, or without passwords using Slack or WhatsApp. Getting started is very easy. Use one of more than 40 SDKs and add a few lines of code. No credit card required. Get the free plan at auth0.io/SERadio. That's auth0.io/SERadio. Auth0 is trusted by developers at Atlassian, Mozilla, Optimizely, and Financial Times. Try it out at auth0.io/SERadio and get back time building core features.
Hello, this is Matthew Farwell for Software Engineering Radio. Today's episode is about managing secrets with Armon Dadgar. Armon is the CTO of HashiCorp, where he brings distributed systems to the world of DevOps tooling. He has worked on Nomad, Vault, Terraform, Consul, and Surf at HashiCorp. Armon, welcome to Software Engineering Radio.
Thanks so much, Matthew, for having me.
As research for this episode, I was actually going through the back catalogue of Software Engineering Radio, and we've covered quite a few of the HashiCorp products in the past. For instance, episode 264, James Phillips on Service Discovery, which covered Consul. Episode 289, James Turnbull on Declarative Programming, which covered Terraform. And of course, in 2014, episode 207, with Mitchell Hashimoto on the Vagrant project. So at least HashiCorp products seems to be popular, at least on this podcast. Today, we're going to talk about secrets management. So I think we'll need to start with a few definitions. So what is a secret?
Sure. Yeah, I think this is I think the whole space around secret management is kind of a new and emerging set of definitions. And, the way we like to describe it is really, let's be very clear about what we consider a piece of secret information versus what we consider sort of merely sensitive. And the kind of definitions we like to use is anything that can be used to authenticate or authorize is what we consider a secret. So just to make that concrete, a username and password is secret because I can use it to actually log into a system. And then similarly, if I have, an API token, I can use that to make a request to an API service, and that token grants me the right level of authentication and authorization to make a request. And sort of then the kind of third category, something maybe like an SSL certificate or a TLS certificate, where by presenting this to another counterparty, I'm proving my identity, which then is allowing me to sort of be authenticated or authorized. And so those kind of things, anything that kind of is granting me access to a system or elevating my access to a system, is what we consider a secret.
So we're not talking about things like KeePass or password safe or 1Password?
So those kind of systems will typically hold on to secret information as well. So if I'm using something like 1Password, it's holding on to usernames and passwords and API tokens as well, which are secret. The kind of space that we're in is really more about how do we think about secret management for sort of our applications. So I have a web service that needs to talk to a database, or I have an API service that needs to talk to Amazon, and so a system like that won't be able to log into an interactive application like 1Password, right? So 1Password is really a lot more, that class of tool is a lot more suited for me, an end user on my personal laptop, and less suited for an application running in a data center.
Okay, so why do systems need secrets?
That's a great question. It really comes down to, what is the security posture we want to take within our data centers? And I think, in some sense, there's a reason why we didn't talk about these kinds of systems a few years ago, which was the assumption used to be, if I have an app running in my data center, it's running on a private network, and that private network is secure. And so, yes, my database needs, a username and password to connect to it, but I'll just use the default, root, for the database, and I'll just hard code that in my application to connect to the database with root. And I think what we've seen increasingly over the last few years is that's a bad assumption. The assumption that our network is somehow perfectly secure. Anytime we open up the news, it's almost like a weekly basis. It's like, what was the latest company to get hacked? And so that's really what's driving this, is this sort of mentality shift to say, actually, my network isn't secure. And at some point, there's going to be a bug in my application or my operating system or some piece of middleware that I depend on that's going to let an attacker get on my network. And so, maybe my database password shouldn't be, root.
So what is secrets management?
Yeah, so secret management, that's a great question, is acknowledging, okay, if we have this class of secrets, right, database credentials and API tokens and sort of certificates, how do we manage them, right? And when we say management, we really mean kind of a few things, which is how are we distributing that secret to the end application? So I have a web server, it needs to talk to a database, so therefore it needs the username and password of the database. How do I actually get that password to the web server? How do I update that thing? So, a sort of good practice in security is, credentials should not last forever. So I don't want my database password to be the same thing till the end of time. So how do I update that, but then make sure my web server actually gets an appropriately updated password so it can connect to the database? And then sort of the flip side is, suppose we do get breached, suppose there is a compromise and an attacker gets on our network or gets to our database, how do we revoke that secret? How do we update it? How do we sort of react if there is a compromise? And so those kind of questions, answering those questions and building a process around that is really what secret management is.
So why do we need to share the secrets? You said we need to share the secrets between the servers. So imagine I've got 5 web servers which are logging into one single database.
Yep.
Why do I need to share secrets between those things?
Yeah.
Why can't I just have 5 logins?
You can have 5 logins, but the question becomes, how does the web server actually get the username and password to connect to the database? And that is sort of the core heart of secret management. So my web server boots, where does it get this? Does it get the username and password just from a configuration file? And if it gets it from a configuration file, how did that secret get there? Did a human operator manually SSH into the machine and populate the username and password for the web server? Or was it driven by, was it just hard coded in plain text? And now if I'm able to access any of the machines, I can just see what the username and password is on disk. Or if that file is stored in GitHub in plain text, I can just access GitHub and see what the database credentials are. And so in some sense, the surface area of access is too wide. Anyone could see these credentials.
Why is secrets management hard?
I think that's a great question. Why is it hard? The challenge of it becomes, I think it's even bigger than just secret management. It kind of speaks to the challenge of security, which is, when we're solving many problems, we can think about the problem in kind of this localized way. We can think about, okay, I just care about, this performance problem of one application, right? And I can profile that and understand where the bottleneck is and fix it in this very isolated place. Security has the opposite problem, which is it's incredibly holistic, right? If I'm an attacker who says, I want to break into this company or there's data I want to exfiltrate, I'm not going to figure out, what's the most secure part of that application and let me go attack that. I'm going to say, let me find any weakness in the system and exploit that. And so the mentality flips where all of a sudden it's not about this, how do I identify this very localized problem and fix that? It becomes a holistic understanding of what does my security story look like end to end? Because security flows like water. It finds the path of least resistance. And so the challenge with secret management is how do you think about, the life cycle of a secret, let's say a username and password from your database, and the whole life cycle of where does the secret get defined, where does it get stored, who has access to it, how do I distribute that secret to the web servers and the APIs and the humans who need access to it. And thinking about that entire life cycle chain in a way where you say, okay, at no point can the answer be the password is in plain text. And it can't be that anyone can access it, right? Because all of a sudden, if at any of those steps that is true, that's where the attacker is going to get to it. It's not going to be within the encrypted part of the system. It's going to be within the plain text part of the system.
Okay, so even if I encrypt it if I'm entering it manually via SSH, it's still entered in plain text in the configuration file, for instance.
Correct, right.
Okay. Are there different categories of secrets?
Oh, that's interesting. So like within secrets themselves, I mean, I'm sure certainly there's secrets that are more sensitive than others. And there's different types of secrets. So, a few that we gave an example of might be, username and password versus API token versus SSL credential. But then the question becomes, what do those systems give you access to? So I might have a username and password that gives me read-only access to a database. That sort of secret is less sensitive than, the username and password that gives me root access to a system. And so there's different levels of sort of severity, I guess, associated with them, and then many different types of secret material.
Do they change over time?
Ideally. So this is, a big philosophical point for us, is this notion that, historically the way secrets were thought about was purely in the, we need a central place to kind of, in quotes, vault the secrets, where we just need to put the secrets in there, and it's a static username and password, and that username and password never changes, but it's encrypted in this one central place. And then applications that need it can pull it out of the central place, and users who need it can pull it out of the central place, but it's not changing. And our view is, it ignores the problem that, sure, okay, it's super secure within that central vault, but the moment, Alice or Bob pull it out of the system, they're like, it's sort of annoying to have to go to the central thing. I'm just going to put it on my desktop as a text file that says, here's the database password, so I don't have to bother go talk to the vault, or I'm going to write it on a sticky note. And in the case of an application, the applications oftentimes do a terrible job, keeping anything secret. They'll end up logging it out to their logs, or they'll be connected to New Relic, and New Relic will suck it up as an environment variable, and it's available there. Or, the system will have a traceback, and it prints it as part of the debug screen. It's like, here's the database username and password. And so, it's kind of like, if you've ever told a secret to a friend, most people do a terrible job keeping a secret, right? It's like before you know it, it kind of proliferates everywhere. And applications are sort of even worse. They tend to leak it everywhere. So this kind of gets to our philosophy of, if secrets aren't changing all the time, they're not secret for very long, right? Like you have to assume at some point, either an application or a human is exposing it to a system that's not properly encrypting it, not properly access controlling it, and it, you have to assume it's not really privileged. So our view is, how do we actually get to a place where secrets are very ephemeral, right? Think almost like a one-time password type thing, which is like every time I'm logging into a database, it should be a new randomly generated password. Kind of like a 2FA code, right? I should get a new PIN every time, so that even if I write that PIN on a piece of paper or I leak it in a log file, that it's invalid the next time around you try and use it. And so in an ideal world, the secrets should be changing all the time.
You said 2FA, just could you clarify what that means?
Sorry, two-factor authentication. So like anytime you log in, it sends you like a text message, or use like Google Authenticator.
Oh, okay. So does that mean we need to think about secrets which change quickly, or secrets that change slowly? Because it seems to me there's different use cases for both. Totally.
So one of the things we talk about within Vault is we introduce this idea of a dynamic secret. So of course there's going to be all sorts of static secrets that, I put in the username and password, and that username and password doesn't really change until I manually change it and come in and update Vault.
Could you give an example of that, of the use of something like that?
Sure. A perfect example of sort of a static secret might be my, the login to my laptop as an example, right? The first time I set it up, I say, username Armon, password 1234, and until such time as I come in and, change my password and update it, it's going to stay static. It's going to be the same thing. Versus, we have this notion of a dynamic secret where every time I request access to a system, the system will generate a new dynamic one for me. So here's an example of it is, I might have a database within my organization, it's my MySQL server, and instead of my, username and password always being the same thing, I go and I talk to Vault and say, hey, I need a read-only credential to the MySQL, or I need a read-write credential to the MySQL server. Vault then goes back and talks to MySQL and generates a dynamic username and a dynamic password that's specific to that one request and hands it back to me and says, here you go, here's your username and password, and by the way, it's only valid for the next 24 hours. And so 24 hours later, Vault talks to MySQL and deletes that credential. And so in that sort of an interaction, every time I'm talking to the database or every time I request a credential, I get a different one back. And so that, I think, is sort of that two-speed mode where it's like, yeah, there's a set of static, very slow changing things like my personal login to my laptop. But how do we move away from that model to one where, per request or per 24 hours, it's a different secret?
Another example of a secret which doesn't change particularly rapidly would be something like a backup. So if you're encrypting your backups,
right,
you wouldn't want to change that secret very often, I would imagine.
Right. Yeah, that's a great example. And something you might want to do with a backup is maybe you're sharing the same, let's call it, you assign a password that's encrypting the backup. That password, might be actually protecting a different set of encryption keys each time. So every day when the backup takes place, instead of sharing maybe the same encryption key every single day, can each backup be encrypted with a different key? And then the underlying encryption key could be protected by the same password, right? So this is kind of like a one password or key pass type thing, which is, I only have to remember that kind of one password, but it's being encrypted with sort of a different set of values each time. And that way,
okay, so you generate a key.
Exactly.
Okay, using a pass. Okay, that's fine. How does an application get hold of a secret in a secrets management system?
That's a great question. And that is, I think, in some sense, the crux of the challenge. It's this problem called, it's sort of the secret zero problem or the bootstrapping problem, which is, I'm a web server, I just boot up. How do I now get access to the secrets I need? How do I prove that I'm a web server? And so that, you'll see that referred to by a few different names, which is, bootstrapping or secret zero, or sort of the last mile problem of secret management, which is the central vault has to somehow establish trust with the client who's requesting these secrets. So, to pull that back then one level further, effectively, one way to think about it is kind of like a web of trust, right? Which is, think about how a new employee maybe starts at a company, which is you have an existing set of employees who are trusted. They already have, their username and password to log in. And the first day they show up, HR's like, great, welcome to the company, Alice. Your username is Alice, and here's your temporary password, 12345. The first time you're going to log in, you're going to be prompted to reset it. And so that sort of onboarding flow, the day before, Alice was not trusted. She was not a member of the organization, and so she had no access to any of the internal systems. But then upon starting, she was sort of securely introduced to the company, right? They sort of looked at her ID card, they looked at her letter of employment that said, okay, Alice should be starting. It matches her ID, and she looks the same as she looks like in her driver's license. Great, here's your username and password. Welcome to the company. And that is sort of analogous to what's happening with the applications, which is, in some sense, you tie into the process of booting that web server. And so when the web server comes in, there's sort of a provisioning process. So maybe you're connecting to Amazon and saying, boot me a new VM, and it should be, a web server. And then, the way you'll tie that back into these systems is kind of the same way HR does the onboarding, which is they'll be like, great, okay, we know there should be a web server booting. You appear to be a web server, and you look like the VM Amazon said it was going to boot. Welcome to the organization. Here's the secrets for being a web server. So it's sort of a very similar process. You're kind of extending this web of trust from a set of systems that you trust into this new thing that matches, that looks like something you should be trusting.
Imagine that for my web server with 5 different servers and one single database, I want to introduce a more formal or more secure secrets management system into my product. Given the constraints that we just talked about, I guess we should start with some sort of threat modeling.
Yeah, that's a great point. When we talk about the threat modeling around secret management, there's really 2 classes of threats. One is sort of the obvious one is sort of external threat. These are people or applications who should have no access at all, right? They're sort of malicious attackers or outsiders. And the threat model for them is they should have no access to anything ever, basically. And then you have the second class, which was actually the much more challenging one, which is the insiders, right? So these are people or applications that should have access to the system, but only access to like the relevant subset of information they need. So the web server should have access to, only the credentials it needs to be a web service, whether it's the database password only. And then you might have an API server that needs access to both the database and, let's say, an Amazon API token. And so the internal threat is slightly different, which is how do we prove you are who you say you are, and that we scope what you have access to only what's relevant for you. Versus an outsider is much simpler, which is you should just have no access to anything ever.
So with I don't really want to go into threat modeling too deeply, but what sort of threats can good secret management help us with?
That's a good question. So what it really comes down to is, when we talk about security, there's kind of three problems really, or three sort of workflows we have to think about. One is how do we prevent sort of an attack from happening, prevent a compromise from happening. It's sort of step one, right? And an ounce of prevention is worth a pound of cure. And really what that comes down to is saying, let's try and make things as secure as possible and restrict access to kind of a need to know basis. But inevitably breaches happen. No security is perfect, right? No sort of authorization model is perfect. So then the second class of concern becomes, okay, how do I detect it when something goes wrong? So my prevention has failed. Now I need to have a good story around how I detect that a breach has happened and what data was accessed and who, what, where, when, and why is sort of the questions we want to be able to answer. And then that last category is how do we mitigate it, right? So now we tried to prevent it, we failed. We detected it and we know sort of what is the surface area of access and compromise, and now what do we do about it? And that's the mitigation. And so if we have a good story around this and we do our threat modeling right, then we can answer kind of these three class of questions, which is, okay, have we done everything possible to prevent it and scoped down the access to just need to know? The web server only has access to the one database. The API only has access to the things it needs, so on and so forth. Then from the detection, have we done the proper work in terms of audit logging capability so that if that credential gets leaked and our web server is hacked, we can see, what are all the secrets that were accessed that maybe shouldn't have been. And then sort of the final bit is, do we understand what needs to be done to mitigate this attack? So do we know how we would change the database password? Do we know how we would, change out the username and password, block access to future things, so on and so forth, how we want to react? And so if we do a good job with the threat modeling, we have a good answer for all three of these categories.
It's not just the secrets that could be stolen as well. It could be sensitive data.
Correct.
As well. So sensitive data being things like credit card numbers, social security numbers, that sort of thing.
Exactly. And that's an important distinction we make is between sort of secret data, which is giving you access to things, right? So authorizing or authenticating. And then the sensitive data, which is protected by it. So once you've breached sort of the secret and you have access to sort of a credential you shouldn't, that's what's letting you trap into all that sensitive information.
So it would be nice to know what that person had access to at the point where they were the data was compromised.
Right, and how long they had access for it and all those kind of good questions. Okay.
So what are some of the anti-patterns of secret management?
How much time do we have? I think probably the biggest anti-pattern, I'd say is, probably there's two or three of them. One is, what we refer to as secret sprawl, right? And secret sprawl is where secrets are just defined everywhere, right? They're hard-coded in the application. They're in plain text and config files, they're in GitHub, they're sort of littered in our configuration management, they're in Dropbox and a wiki, so on and so forth. There's this sort of extreme decentralization. And actually, I shouldn't even use the word extreme. It's so common that you could hardly consider it extreme. And the challenge with something like that is you can't really answer any of the hard questions, which is, who had access to this secret, right? When it's in 15 different systems and most of them are globally readable, the answer might be every user at the company, every, application, anyone on the network. And so the answer ends up becoming all to every question. And so then you go to the next question, which is like, okay, everyone had access. and now there's been a breach. Well, where did that breach happen? Well, there's no audit logs because it's in 15 different systems, right? And the secret never changes. So did they access the secret yesterday or 2 years ago? And then just decided to wait until today to use it, right? Without that sort of audit trail, it is very hard to reverse back, what happened. And so that's sort of the detection question. And then you get to prevention and say, okay, well, now what do we do about it? Well, it's defined in 15 different systems in plain text all over the place. So, there's not much you can do.
Don't do that.
And so that's probably the number one anti-pattern is probably this decentralization. So even if we had centralized, even if it was still in plain text, right, and we didn't do access control and we didn't do sort of any of the other good things, but we said, actually, it's only defined in this one place, at least our answers get slightly better to these other questions, which is, okay, well, we know it must have come from this place. Maybe there's web server logs for that one system that we can access. If we need to change the password, we only have to change it in one place and not 15. And so, it's not a great story, but it's at least a vastly better story than sort of the sprawl that we normally see.
So just before we moved on to the second couple of anti-patterns, I have a question here. Does a good centralized configuration management tool such as Zookeeper or ATCD or Console help with secrets management?
It improves the situation. Let's put it that way. I wouldn't say, there's the good, bad, and the ugly. That moves us from maybe the ugly to the bad, where at least now we have that sort of centrality. But when we look at systems like Zookeeper or etcd or Console, none of them are really designed with secrets in mind. So they're not worried about encrypting of the secrets. They're not worried about sort of fine-grained access control and auditing, because they're assuming that they're being used for much less sensitive information.
Okay, sorry, just about after that aside, can we go back to the anti-patterns?
Sure. Yeah, so if sort of the decentralization is kind of the worst offender, probably the number two would be keeping things in plain text. Even if we move things to being centralized, the problem is still, if we're not encrypting these secrets, then it's really still hard to answer some of these questions in a very fine way, right? If it's in plain text everywhere, then really we've decoupled kind of once I've given it away, or once I've written it to disk or written it to the wire, I don't have a strong assurance of, did it get stored in some other system, right? Versus if we're encrypting all of these secrets, then really only the key holders are the ones who could ever decrypt it, right? And those become a much tighter set of people that's much more controlled. And then you're not as worried if someone copied out this encrypted value from the database, it's sort of like, oh well, right? Like, unless you have the encryption key, it's just a meaningless encrypted value to you. So that's probably like number two, is keeping things in plain text in various places.
But even with that, you have the key problem again. So if coming back to if we're putting the username and password for the database, we're encrypting it on the web servers, then that means that the web servers have to have the encryption key to be able to decrypt it, so it's still on the web servers.
Well, ideally, if we're doing sort of secret management, we have a central key holder, right? So that the web servers are not the sort of the end point in terms of where the decryption is happening. It's that the central kind of key management solution, the central secret management solution, is encrypting its own data and doing the decryption just in time before handing it out to the client, if that makes sense.
Okay, so this is what they call a trusted third party.
Exactly. So we're sort of trusting the central authority, the central key management system to do things properly. But now we move from a place where all of our web servers have these encryption keys to there's one system that we need to secure and lock down, right?
Okay, but the web server still has to have access to...
Correct. The web server has to be able to go talk and query out of that system.
Okay, and the third anti-pattern?
Third anti-pattern. I think the third anti-pattern, I think this is going to be kind of almost a two-part answer. The third part anti-pattern is sharing of credentials, and those credentials being long-lived, right? And these things are sort of intertwined. And the reason I mean that is, let's say I have 5 web servers, and all of them are sharing the same username and password forever, right? Because we're not changing them ever. And now we notice that our database is compromised. The question becomes, okay, well, which 5 of those systems and at what time were they compromised? And this becomes a really hard question to answer because there's a sharing of that same value between all of the different clients, and they've been sharing it for a very long time. And so there's not a good way of bounding the space or time in which it was compromised. And so moving away from that and saying, actually, and sort of the analogy of that would be, imagine if every employee at a company had the exact same login, right? It would be very strange from an organizational perspective because it's almost more obvious when it's people. And you'd say, yeah, obviously, Alice, Bob, and Charlie should have different credentials so that we know who did what. But we don't necessarily think that way when it comes to applications, right? Which is strange because they have the same problem. And so I think that sharing becomes sort of that third anti-pattern.
So what you're saying is, so each of these web servers should have 5 different usernames and passwords. That's a good thing to do anyway.
Right, exactly.
Okay.
And that they should be forced to rotate as well in the same way, we force people in an organization to change their password every some number of, months or whatever.
Okay. And the long-livedness?
So the long-livedness is so once we've said, okay, actually every web server is going to have a different password. In some sense, now we've bounded space. So we know if this credential leaked, we know it must be web server 5, let's say, that was compromised. But if it's been the same password for 5 years, we don't know, was it compromised last week or 5 years ago? And so then getting into these shorter-lived credentials lets us, bound that time. So if the password changes, every day, then we know, on this day is when the compromise took place, as opposed to sometime in the last 5 years.
But you might not necessarily know that the password has changed because the auditing happens at the user level at the user level.
Right. And I think this becomes a value of a good secret management solution, is that it should be able to give you that sort of provenance of, what was the username and password and at what time, so that you can sort of pinpoint that sort of, where it was in terms of, what was the origin of the compromise, but what was the rough timeline.
Don't let security checks be a burden on your software deployment. Veracode Greenlight gives you secure coding feedback in seconds directly in your IDE. Try Veracode Greenlight for Eclipse free for 30 days and tap into Veracode's binary static analysis engine, delivering in-depth and accurate results to developers in just seconds. Request your trial of Greenlight for Eclipse today by visiting veracode.com/greenlight-trial. Not using Eclipse? Visit veracode.com/greenlight for information on Visual Studio and IntelliJ plugins.
How do we update a secret? And how often should we do it?
That's a great question. I think it really comes down to sort of this tension between how good we get at secret management, right? So I guess let me start from sort of the platonic ideal. The platonic ideal would be every single time that I connect to the database, let's just say, it's a different password. Because that is now the ideal scenario. As I can say, I can pinpoint down to this exact interaction when this happened, right? In some sense, that'd be kind of the same as, I'm going to rekey my house every time I open the door. Every time I get into my house, I'm rekeying it, and now I have a new key. It becomes very impractical, right? And so there's a certain cost and overhead associated with doing this. So the real world trade-off becomes sort of finding that middle ground where you say, okay, maybe rekeying every single time is excessive and extreme. And then it's really about your risk tolerance, right? Do I want to do it daily? Do I want to do it weekly? Do I want to do it monthly? And so there's no perfect answer. It really comes down to risk tolerance, right? If I was, managing nuclear launch codes, probably my risk tolerance would be incredibly low, and I would make an effort to get those things, and in fact they do. They're all one-time passwords, so they're quite literally only usable one time for that reason. Versus if I'm managing, my pantry, I'm probably not putting a lock on it.
How should I revoke a secret? Is this the same process?
So revoking a secret's super interesting, and I think really comes to, where we're seeing interest in some of the more modern secret management systems. The challenge in the past is if we're living in this world of extreme decentralization, and we really don't think about sort of the challenges in terms of updating, then revocation can be basically impossible, right? So if I have my 5 web servers, and all 5 of them share a username and password, then, if I know that password has now leaked, I can't go to the database and just revoke it, because all of a sudden, all 5 of the servers will get disconnected at the same time. So this sharing is actually causing this problem where, if it was a severe enough breach, maybe we're okay with that. We're saying, just take down the whole service until we figure this out, revoke access from everything. But if we really want to be more fine-grained and say, actually, we just want to revoke the credential from the system that we believe to have been compromised, you have to, a prerequisite of that is that you're not doing a sharing and that you have a centrality of management that lets you actually do that. Because if it's hard-coded in the application, there's not an easy way to recompile the application and provide the new credential to it.
So how much auditing do we need from our secrets management tool?
Ideally, everything, right? Anything going in and out would be auditable, right? And I think this goes back to, in the general case, we're not really looking at it. But when that breach happens, we really want to have as much of the forensic information available to us as possible. So who did it? When did they do it? Where did they do it from? All of that information becomes super useful. And so the way we sort of think about it is every request should be audited so that you have that full trail.
Any request to the secrets management system or any request to the database, for instance?
At a minimum, for sure, to the secret management system, every request. And then, if you can, it again goes back to this question of, that data starts to become huge after a while, right? And that there's that similar sort of overhead of, if I have every access to my underlying database system, is that a manageable amount of data? And that really ties back to your risk profile, which is like, if it's the nuclear launch codes, probably audit every one of those things and, pay Splunk a little more.
And this all ties back to the threat modeling as well, because you have to decide what you want to protect and which bits.
Exactly. And this is, I think, the fun nuance of security is that in some sense, and I hope I don't seem like I'm trying to dodge these questions, but security is so contextual, unlike something else, where some of these other areas, there is a best practice in terms of how security, service discovery should be done, as an example. There's just like, here's the right way to do it, right? Whereas security, it's so dependent on what is your risk profile? What is the sort of cost of a mistake? And the right answer changes, basically.
Okay. This is kind of an open question. If given the choice between focusing on secrets management or network or application security, where would you draw the line?
Ooh, my view is there's sort of an 80-20 rule with everything. So when we look at network security, I think, the end-all be-all assumption for a long time was we're going to build this network perimeter and then put, a single front door and put our firewall and our intrusion detection and sort of all of our security at that one point and basically construct an impenetrable network. And that was the assumption, was that it's this sort of castle and moat way of looking at the world. And the challenge with that assumption becomes, it's like, okay, well, what if they get in, right? What if, let's just play the kind of hypothetical. We've invested so much energy on fortifying the wall that the inside of the network is completely soft. And so the moment the attacker is in, it's game over. And so to me, this becomes this sort of perfect experiment of like that 80-20 rule, which is, okay, it's worth building that network perimeter for sure and investing to that 80% of sort of the defense, but then assume they're going to get in and don't try and get that to 100%. Instead, look at sort of the next class of protection, which is, okay, if they're in, then what? If your assumption is if when they're in, it's game over, that's a bad answer. And that's where it makes sense to invest in things like secret management and get that to the 80-20% rule, right? Where you say, okay, can we put in the investment and effort so that, we get our secret management story to the 80% mark of preventing sort of excessive amount of access to things, having auditing, having a revocation story. And similar with application security is, how do we get to sort of 80-20 on all 3 of these defenses, which are independent defenses, as opposed to let's get one defense to 100%, and if it fails, game over.
So how has secrets management changed? Talking of this, how has secrets management changed with the move to the cloud?
So, in some sense, the move to the cloud has been, I think the camel that broke the back on the assumption that the network perimeter was secure, right? I think we held on to that assumption, longer than we should have. in the physical data center world, because a physical data center quite literally has 4 walls and 1 door. And so there was this sort of more convenient analogy to be made. And it sort of ignores the fact that we had VPNs and multiple data centers connected to one another and things like that. But as we move to cloud, it becomes obvious. A cloud is nebulous. There is no 4 walls. There is no front door. And so that whole analogy, that whole way of thinking just starts breaking down. And it makes much more clear that, okay, while we can sort of put together, a network perimeter, it's definitely not as sort of robust as what we used to have. And it forces us to take that assumption that at some point this network will be breached. And what should our posture be? How do we bring in secret management and not have the inside of the network be completely soft?
Okay, so the idea is as you say, in the 80-20 rule for application security, secrets management, and network security.
Right, exactly.
Again. Okay. One of the other hosts, Kim Carter, does a lot of work on security, and in his book, The Holistic InfoSec for Web Developers, one of the statistics that he quotes is that 71 for healthcare providers, 71% of all attackers were carried out by insiders, some of which were malicious and some of which were inadvertent. How does that change our approach to secrets management?
Yeah, that's a great question. And I think sort of perfectly maps back into that sort of challenge of the castle and moat thinking, which is, if we only think about the adversary as being an external outsider, then all we have to do is build a really tall wall. But the moment we allow our threat model to include, someone on the inside of the wall could be malicious, then it really breaks down. It doesn't matter how tall the wall is on the outside anymore. It really becomes about, okay, how do you give the individuals on the inside enough, credentials that they can do their job, right? We can't go to a world where we say we're not going to trust anybody and no one has access to anything, because otherwise, it becomes very hard to do our actual work. But if I decide, I didn't get the raise I wanted, I'm going to become a malicious actor, how do I make sure that my blast radius is limited to only the things that I actually needed access to do my job? And I think this perfectly highlights that challenge of perfect security, is I might need access to the database to do my normal job. So I can't be in a world where I just don't have access to it. But if I decide to be malicious with that access, that's when we move from prevention to detection. Because at that point, there was no way to prevent that. I needed the access fundamentally to do my job, but I didn't need to maybe exfiltrate the data and, share it. And so, I think this highlights, that 71%, I think is totally accurate, right? External attacks are actually relatively rare compared to the insider attacks. And it highlights that need to sort of bring secret management in and invest not only in prevention, but also detection and mitigation.
So should I be encrypting everything?
Yes, for sure. For sure. Everything should be encrypted. I think...
so even my database?
Especially
or the stuff
your
in
database.
the database?
Especially your database. Yeah, I mean...
Or just the sensitive information in the database?
Yeah, I mean, I think if it's truly, non-sensitive information, then I guess, it might not be worth that investment. But the way we think about it is, how upset are you going to be if this ends up on CNN.com, right? Like, if this gets leaked to the internet, are you going to wish it was encrypted or not, right? And if the answer is not really, then okay, maybe you don't need to apply encryption. But if the answer is yeah, that would be a bad day for us, then it's probably a good idea. And I think the other, it comes back to that notion, the question you asked, which is, how much should I invest in network security versus, network and app and secret management? And having these, what it comes down to is having independent sort of failure domains, right? So if I say I'm only investing in network security and that thing fails, then it's game over, right? Versus if I have these 3 different layers of defenses, then even if one system fails, I have an opportunity to apply sort of defense in depth with these other systems. Encrypting the database is similar. If I say, the username and password protecting the database is the end-all be-all defense, what if someone who's an insider gets access to it? What if an attacker gets access to it? Is it just game over? Versus if, great, now you have access to the database, but all the information you really care about is encrypted, this sort of second factor, this defense in depth becomes, are you a key holder, right? Or are you authorized to go talk to, a key holding system to do decryption of that data? Because if not, now you have this totally independent second factor that also has to be breached.
Okay, I'd like to move on to what some of the systems that are available for secrets management. We've already mentioned Vault, but if I look up on the internet systems for secrets management, there are a multitude. There are encrypted data bags in Chef Vault, Hiera IAM, HashiCorp Vault, Kawiz, and that's just ignoring the ones which are paid solutions. If I assume that I've decided I don't want to roll my own secrets management.
Good assumption.
How do I go about choosing a secrets management tool?
That's a good question. I mean, I'll be upfront that clearly there's going to be some vendor bias here, right? So to just in the interest of transparency, but I think it comes down to understanding, a few things, which is like, what's your environment look like, right? And what are your needs from a secret management system, right? And I think it's kind of, if you need the Camry, getting the Ferrari might be overkill. And I think part of the challenge becomes these different systems are oftentimes built assuming a very particular environment, right? And so, let's just take Kawiz as an example. It was an internal project at Square that was spun out. Well, the result of that is it makes a lot of assumptions about what the environment looks like that are perfectly valid for Square because it was built for their environment. And so it solves Square's problems in Square's environment. And so if your problem looks the same and your environment looks similar enough, it might be a great solution for you. It might be a great fit. Versus if you look at a tool like HashiCorp Vault, we are a toolsmith, right? So in some sense, we're not building it for ourselves. We're building it for other people. And so our sort of view going in is, how do we minimize the assumptions about what the environment looks like and support the broadest array of environments? And how do we support everyone from, hey, it's a 2-person side project all the way to, we have Fortune 20 customers. And so, what our goals are not necessarily the same goals as Kawiz in terms of supporting Square's needs.
So how do I go about authenticating myself with Vault?
That's a great question, and that goes to that sort of secure bootstrap. The sort of heart of that question, it's tied very intimately to how you actually provision and deploy applications. So what I mean by that is, let's say I'm using Amazon and I'm booting a VM in Amazon. Vault ties in and treats Amazon as a trusted third party. So the sort of analogy to be made is, when I started at the company, they trusted the federal government to issue me a driver's license that says this is Armon. And that's being used by HR to say, yes, you can join the organization. And in a similar case, when a VM boots and connects to Vault and says, I'm the web server, we're looking at the identity document provided by Amazon that says this machine is who it says it is. And we're saying, great, we trust Amazon to have sort of done the cryptographic identity correctly. You're allowed in. And so the question becomes sort of, based on the platform you're running on, can we establish a chain of trust between our system Vault and the client that's coming in? And so, we work closely with Amazon and Google and Microsoft and so on, all the major kind of cloud platforms to do that sort of integration with them.
Okay, so, but that's something you've got to think about with virtually any secrets management tool. How do you integrate with the environment with AWS,
right, correct.
for instance?
Exactly. You have to establish that sort of a chain of trust between your secret management system and the application. And so that almost invariably there's some intermediary there. And so it really becomes a question of, does the tool integrate into the system that you're using, the environment that you're using?
So this could be analogous to Puppet. So when the Puppet client first connects to the Puppet server then has to say, yes, I believe this Puppet client.
Exactly. Identical problem.
Okay. Is it worth using Vault, and indeed any secrets management, on a single machine if we're not sharing the keys between multi-machines?
That's an interesting question. I mean, the reality might be no. It might be that it's actually not worth it. And, so let me sort of ground that just so that this doesn't get quoted out of context. I'm making a series of assumptions here, which is, if our whole application runs on one machine, what is the risk profile here, right? And how big is the team that's managing this thing, right? And is it worth the cognitive overhead of learning a secret management system, deploying it, operating it, if our risk profile is a single machine? And so I'm making a number of assumptions in terms of, how sensitive this application is and how big the team is. But, very likely if it's only one machine, it's maybe a very, very small team and the risk profile is relatively limited, and it might not justify that investment. If it so happens that machine is securing, millions of dollars in transactions, then yeah, surely the risk profile is high enough that it's worth it. But it's a very nuanced answer.
A very interesting answer. There's another use case here, is that you are creating software which is deployed on a client site, which is a single machine.
Oh, interesting. Okay. Yep. So in that sort of an environment, I wouldn't think about it as a single machine unless there's only one client. If there's many different client sites that are all being sort of centrally managed and provisioned, then really at that central point is where you have the opportunity to say, actually, these 100 client sites that have independent credentials can be centrally managed and reduces the surface area of access and risk.
Okay. So to recap, when people are starting to think about secrets management in the large like this, what are the first three things that they should do?
First three things they should do. Okay. So the first three things I would do is kind of get a handle on a few different questions. Question one is, what are all of our secrets and where are they? That's question one. Question two would be, which applications and which people should have access to what secrets, right? So figuring out, in some sense, what is our trust model here? Who needs access to what? And then question three is, what's the simplest path of getting all of those secrets to one place and making sure that access model that we just defined in sort of question two is what's enforced? Like that to me would be the three steps, right? Because I think step one is surprisingly hard because most organizations are coming from a place of decentralization. It actually becomes a whole process of discovery to understand where are all of these things defined. Are they hard-coded in the app or in GitHub, or where are they? And so having that map of here's where everything is, here's who should have access to all of it, and then how do we actually get there? What's the path to centralizing and enforcing that access?
And should we be thinking about the three kinds of threats that you're talking about, the prevention of compromise, detection of compromise, and mitigation of compromise?
Totally. And I think again, that follows sort of the 80-20 rule, which is prevention is in some sense 80% of it. 80% of the value is the prevention. And so if you're starting from a place of key sprawl and the assumption that these things are plain text everywhere, you're going to get the most bang from the buck from just getting the prevention in place. And then, the follow-on to that becomes sort of the next highest value becomes, let's set up the audit logging capability and have the ability to do the detection and forensics that we need. And then sort of the final level of maturity would be, let's have a well-defined sort of mitigation strategy in place. But I think in terms of that 80-20, 80% of the value is in getting the prevention going and just enabling basic audit logging.
Is there anything else I should have asked you?
I think one thing that we like to talk about is, secret management in some sense it's a spectrum, right? It's not just a binary. So it's, in terms of the maturity curve of like where you could be on it, I'd be happy to chat a little bit about, okay, even if we implement this sort of central vaulting, what's next, right? Like what are the next few steps from there? Because I don't think you're done.
Okay, and how can people find out more about this subject?
That's a great question. I think it's actually a developing area in many ways. I think that this assumption shift from sort of the soft interior to actually securing it is new. So I think there's limited material. I mean, I think we have a lot of documentation that we provide around the Vault project. In some sense, that doesn't give you the sort of broader level view of what is the challenge. I think if you go onto YouTube and you search sort of secret management, you'll see a number of good talks given either by folks at HashiCorp or folks at Docker, and a few other organizations who have talked about what does modern secret management really mean. And I think those are a great starting point because they sort of lay out, here's the forest of challenges, and let's just kind of understand the landscape before diving into the details.
We had an SE Radio interview with Diego Monica on Docker Security, which was 290, just for anybody who's interested in that. Thank you for joining us today, Armon. Where can people find out more about you?
I'm all over the internet as just Armon. It turns out it's luckily there's little name conflict. So I'm on Twitter as Armon. I'm on LinkedIn. You'll find me kind of all about there. I'm on GitHub as well.
Okay. This is Matthew Farwell for Software Engineering Radio. Thank you for listening.
Thanks so much, Matthew.
Don't let security checks be a burden on your software deployment. Veracode Greenlight gives you secure coding feedback in seconds directly in your IDE. Try Veracode Greenlight for Eclipse free for 30 days and tap into Veracode's binary static analysis engine, delivering in-depth and accurate results to developers in just seconds. Request your trial of Greenlight for Eclipse today by visiting veracode.com/greenlight-trial. Not using Eclipse? Visit veracode.com/greenlight for information on Visual Studio and IntelliJ plugins. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.